Welcome back, guys. I just want you to remember, you've seen the videos before, that we've seen the pressure enthalpy diagram and the pressure volume diagram. Probably you can remember this bell-sized shape here. So probably you're asking yourself, what is this liquid mixture or liquid vapor mixture about? And we're going to analyze that actually, because we are very interested in the mixture of liquid vapors. Why? Well, there's actually a lot of studies on liquid vapor equilibrium. They are in equilibrium. I'm going to explain you why. But in the diagram, that bell represents the vapor liquid mixture. For example, let me show you. You have this a little bit of liquid here, and you got a little bit of gas here. You have gas and you have your liquid. And of course you may have 0%, let's say you started with 100% liquid, and then if you start boiling that, maybe you're going to have later 25% of liquid. That means 75 is already vapor. And if you keep doing that, you're going to eventually turn out all the 100% of liquid to a gas. But the interesting part is right here, the saturation process, or the equilibrium, whatever you want to call it. When we speak about a vapor liquid that is saturated, is essentially a vapor liquid in equilibrium. And what do I mean with that? Well, let's suppose you have the liquid here and you have no gas at the moment. So since there's a, let's say, a vacuum, you will see that the force or pressure of the, let's say, this little atmosphere versus the pressure of this volatility of water, you will see that it is not the same actually. You will have that the pressure of the volatility is greater than the pressure of the atmosphere, and therefore you will be able to volatilize that. But as you keep doing that, you will eventually, these guys are going to get more in quantity. You're going to increase the number of molecules or vapor molecules, and now you will start having, let's say, maybe before was this represented, let's say, pressure of volatility versus pressure of the atmosphere. And in this case, it will be the pressure or partial pressure of the vapor. And you start increasing the pressure, because as you increase the amount of molecules in vapor, you're going to increase the amount of pressure, until eventually you have the pressure, or the partial pressure of the vapor, and the pressure of the liquid. And actually, if you want to calculate them, they will be exactly the same, and that means they are in equilibrium. Maybe one molecule of water will go to the vapor phase, but if that happens, one molecule of vapor will go down into the liquid phase. And that's pretty common, and that can be done either, it doesn't have to be 50-50. You could have actually 5% of liquid and 95% of that in vapor. They are still in equilibrium, and you will see, of course, a little of liquid and a lot of gas here. So what I wanted to tell you guys is that essentially almost every liquid has this phenomenon. Let's say this is water. The only thing probably you know that if you let alone water for a lot of time, you will evaporate all the water. And this is due to the evaporation or volatility of water. It will start going out to the atmosphere, going out. And since the atmosphere is huge, well, you're not going to feel that pressure exerted. But let's say we close that. We have here was an open system, and now it's a closed system. You will start having the same phenomena, because here is still a vacuum and here you have a lot of space. The atmospheric pressure here is relatively low, and this pressure is relatively low as well. But eventually you're going to evaporate all these little molecules, and you're going to achieve a pressure, let's say a pressure of vapor, and the pressure of the volatility. So they are going to be the same, and when that happens, you're going to stop that. And let's say you start with 100 grams of liquid, and now you take that out and you check, and you say it's 23 grams of liquid. Whereas the other 77 grams of the water, well, obviously they are in vapor phase, since this is a closed system. Of course, we are supposing they don't go out from here. So what is exactly this? You're going to find out that this is 23% of liquid and 77% on vapor. And that's what we are very interested about. Wherever there's liquid and a vapor, we're going to be calling this let's say a mixture in which the quality is the number, or it is the distribution of that liquid and vapor masses. Actually, we're going to see that in the next video, how we mathematically calculate the quality, but essentially it's just the amount of vapor divided by the total amount. And why we are talking about this is because the enthalpy, the entropy, the internal energy, the specific volumes, and all those extensive variables that are important to us, or that will be important to us to calculate the first law, will vary depending on the amount of liquid and the amount of vapor you have in that mixture. Of course, you know liquids have relatively low internal energies compared to vapors. Vapors have relatively high internal energies. And you know internal energy is related to enthalpy, or enthalpy is related to internal energy, and this is true as well. Liquids have low internal energy and enthalpy. Vapors have, relatively speaking, higher internal energy and enthalpy.
What's up guys, it's me, Chemical Engineering Guy. So if you like the video, why not push the like button? It really helps me to know if you're liking the videos, or if I should be changing something, or I should be adding something, taking out content, whatever. Also, sharing is caring. So if you got any kind of friends, teachers, colleagues, or whatever kind of person that might be interested in this type of content, why not share it? Sharing helps our community to grow faster in members and in content. If you want to keep track of my activity, videos, uploads, experiments, playlists, whatever content I'm getting on YouTube, be sure to click the subscribe button. Subscribing to the channel is totally free, guys. My dream is to create an online academy of chemical engineering, where everyone can access it in the world. Imagine a place in which the student, the teacher, and the engineer get the best of each other. Thank you guys for the support and the love.